Good morning, Seven Kumagong. My name is Teacher Ella B. Llamas, and I will be your science teacher for today. So I hope that you're having a wonderful day, isn't it? All right, that's good to hear. So before we start our lesson, I want you first to bow your heads and feel the presence of the Lord. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Dear God, we praise and glorify you. Thank you that you love each and every one of us. Help us to learn, enjoy, and share together so that the wonderful world you have made becomes more beautiful every day. Amen. Okay, so again, good morning, class. Thank you so much for that very energetic greetings. So, class monitor, can you please give to me the attendance sheet so that we can check who is absent and who is present? Okay, thank you so much, Nika. So let me just remind you of the following. We have an online classroom rules. So we have here 8 online classroom rules. The first one is you have to be on time. I want you to sign in at least 10 minutes before class. Number 2, I want you to be prepared. All your things must be prepared before joining the class. Number 3, turn on camera. Always turn your camera on so that we can see each other. 'Di ba? Sayang ng kapugian at kagandahan ninyo. Number 4, do not eat. We do not eat during online class session. Number 5, dress appropriately. Wear something comfortable but presentable. Number 6, mute your microphone when you are not talking. Number 7, raise your hand to talk or to ask teacher for help. And the last, you have to enjoy learning. Let's enjoy this new kind of learning. Okay, so for you to do well in this lesson, I want you to take down notes, get your notebook, get your pen, and then jot down notes for those important details. Next, you have to listen carefully. And the last one, I want you to participate actively in our lesson. Okay, so our topic for today is about solutions. So, do you have any idea what is a solution? Yes, Michael. Very good. According to Michael, solution is made up of two substances, which is the solute and the solvent. So, what is a solute? Yes, Jessica. Very good. A solute is the one being dissolved by the solvent. That's correct. And how about the solvent itself? Yes, Jane. Very good. Solvent is the bulk of the solution. Solvent is the one dissolving the solute. Can you please give me an example of a solvent? Nika? Very good. We have water. Water is known as the universal solvent, right? Another example of a solute. Yes, very good. We have sugar, we have salt, etc. Those are examples of solute. So today, we have our learning targets. So at the end of the lesson, you will be able to learn number 1, explain how solutions are formed and what are the different types of solution. Number 2, differentiate concentration based on percent by mass and percent by volume. And number 3, explain how factors affecting solubility could be used in our daily lives. So at the end of the lesson, we're going to go back with this learning target so that we can know, we can figure out whether you really learned with our topic or lesson for today. So let me give you the lesson overview. So we have here the solution. So We have the kinds of solution based on saturation. First is saturated, second supersaturated, and the third one is unsaturated. Next, factors affecting solubility. Number one, natures of solute and solvent. Number two, temperature. Number three, pressure. Number four, particle size. And the fifth one is mechanical stirring. Last is we have the concentration. Under concentration, you're going to learn about percent by mass and percent by volume. So are you excited to be side connected with our lesson? All right, very good. So again, I want you to jot down the important details and listen carefully and participate. Okay, so let us now start. So on our first activity, I want you to write A if you agree with the statement. Write B if you disagree with the statement. All right, so we have here a table before the lesson and after the lesson. So you're going to answer first the before the lesson column. Okay, write A if you agree with the statement, write B if you disagree with the statement. Number one, solutions are always in the form of liquid. Do you agree? Then put A. Disagree? Then put B. All right, let's move on with number two. A mixture of starch and water is an example of solution. A or B? All right. Number three, if the too much sugar was added to water, it will reach a point where it can no longer dissolve more of it. Agree or disagree? Number four, sugar will dissolve faster when added to an iced tea than in hot coffee. Agree or disagree? Number five, a rubbing alcohol label that reads 70% isopropyl alcohol means 70% by volume. Agree or disagree? Number six, the last one, the last statement. A supersaturated solution, when heated, will form saturated solution. Agree or disagree? Okay, wrapped up. All right, so let's check your answer as we go on with our discussion. So basically, a solution, again, is made up of a solvent and a solute. The solvent itself is the largest part of the solution, and the solute is the smallest part of the solution. Normally, in chemistry, solute is the smallest part of the solution. But sometimes it happens that the solute also becomes largest part of the solution. You are going to notice it as we go on with our discussion. Next, the solvent is the largest part of the solution. All right. So for example, in your day-to-day life, when you wake up in the morning, you had your breakfast, you prepare a cup of coffee for your dad or your mom. Of course, you have to get a solute, which is the coffee, and the solvent, which is the hot water. And then you're going to mix them, and then you stir. And after that, there you have a coffee solution. All right. So please do not forget that a solution is made of two substances, the solvent and the solute, and a solution is a homogeneous mixture, meaning you can see only one phase. All right. So for the coffee, it's purely black color. All right. So next, we have the term solubility. So what is solubility? Yes, Jessica, can you please read? Okay, so solubility is the amount of solute that dissolves in a certain amount of solvent at a given temperature and pressure. That is solubility. The amount of solute that dissolves in a certain amount of solvent at a given temperature and pressure. So we have here different factors affecting solubility. The first one is the nature of solute and solvent. When we say nature, it has something to do with the characteristic of that solute and solvent. So we have here the principle like dissolves like. Like dissolves like originated with the rule of thumb in chemistry, which means that polar solutes dissolves with polar solvents. Non-polar solutes dissolves non-polar solvents. So do you get the meaning of nature of solute and solvent? It has something to do with likes dissolves like. If the solute is polar, therefore it can be dissolved with the polar solvents. If the solute is non-polar, it will also be dissolved by a non-polar solvents. So for it to be clear to you, let me give you an example. So the first example is we have an alcohol which is not drunk or drink by your father or uncle. Alcohol is used for sanitizing, and we also have water. When you mix the two, there comes a solution. Therefore, an alcohol is an example of a polar solute, and water is an example of a polar solvent. They become a solution in the end. All right. Next, let me give you also an example of a non-polar solvent being dissolved by dissolving the non-polar solute. So example, we have here a gasoline, a non-polar liquid, which is a good solvent for fats, oil, and grease. That is an example of a non-polar solute. Okay, the non-polar solute is the fat, oil, and grease. The non-polar solvent is the gasoline. Okay, next, we also have here the terms which you should be familiar. We have here miscible liquids. When we say miscible liquids, they can easily dissolve in one another. So that is miscible. All right? They can easily dissolve each other. You call them miscible liquids. If the liquids are not stable or not soluble in each other, that is immiscible. Okay? Again, if the liquids can easily dissolve in one another, that is miscible. But when the liquids are not soluble in each other, that is immiscible. Okay, did you get the term? All right, very good. So, next factor affecting solubility is we have the pressure. So, pressure is actually observed only in the case of gases. So, increase in pressure increases solubility of gas in a liquid. We can actually have an example, which is a can of soda or a Coca-Cola or any brand name of soda. When you open the bottle, you can actually hear a whizzing sound. It's like tss, like that. That is actually the fizzing sound created by the pressure released inside the can of the soda. And another one is there are some bubbles present, right? Uprising inside the bottle. That is actually known as the effervescence. Okay. All right. So number three, we have temperature. So solubility increases when temperature increases. This is only applicable in solid and liquid. Of course, even when we are cooking in the kitchen, we can observe that when a liquid heated, the solubility of the solute increases. For example, I opened the LPG and then I put a pan in the gas stove with water, and then I put 1 teaspoon of salt. If I increase the temperature, what will happen is that this salt will eventually dissolve faster. Did you get me? That is how temperature affects the solubility. Next one, solubility decreases when temperature increases. So in terms of gas, this is different. Solubility decreases when temperature increases. A very known example of this one is the fish kill. Do you know what is a fish kill? Fish kill happens when there is no enough dissolved oxygen for the fishes. So the tendency is that these fishes tends to die because they don't have enough oxygen to breathe. Because of the increase of temperature, the level of dissolved oxygen decreases. Therefore, the fish cannot breathe and they eventually die. And then the fish kill happens. Number four is the particle size. The smaller the size of solute particles, the greater the solubility of solute. Of course, let me give you an example. We have an iodized salt, this one. Right, let me highlight it for you. This is the iodized salt, and this one is the rock salt. So if we're going to get a glass of water with the same size and the same volume of water, let's say in the glass A, you put there the iodized salt. Okay, so let's put here IS, which stands for the iodized salt. And for the container B, you put the rock salt. So which one do you think will have a greater chance of greater solubility? Of course, that will be container A, because according to the principle, the smaller the size of solute particles, the greater their solubility will be. The fifth one is we have the mechanical stirring. So solubility increases with mechanical stirring. Have you experienced having a coffee, preparing a coffee, and then the water that you get is becoming cool, and then you put the coffee. Some of the coffee tends to be on top. So for it to be dissolved, what you do is you get a teaspoon and then you stir, right? So when we stir, the faster the solubility of the coffee, the faster it will dissolve. There you go. So those are the factors affecting solubility. So let us enumerate. The first one is the nature of solute and solvent. That's correct. Second is the pressure. Third is the temperature. Fourth is the particle size. And the fifth one is the mechanical stirring. Okay, so now let's move on with the unsaturated, saturated, and supersaturated solutions. So let me give you an overview. When we say unsaturated solution, there is more solute dissolves. Okay, meaning, let's say I put 100 ml of water to all of this container. All right. So for the first container, container A, I've put 10 grams of sugar. Okay. So when you put the 10 grams of sugar in 100 ml of water, this 10 grams of sugar will eventually dissolve, right? And you cannot see any solid particles beneath or in the bottom of the container. In the container B, that will be considered saturated if no more solute dissolves. So let's say, for example, I already added 10 grams of sugar inside container B, and then I added more, which is 60 grams of sugar. So in this case, the solvent cannot anymore dissolve the sugar. So that will be now called as saturated solution. It means you already reached the saturation point wherein the solvent cannot anymore dissolve the solute itself. That is saturated solution. The last one is we have the container C. Container C, that is supersaturated solution. In this case, let's say there is already 70 grams of sugar in 100 ml of water. You can now see the crystals forming. All right, so that can be now considered as supersaturated. So in the supersaturated solution, crystals may grow beneath, and at the same time, this supersaturated can actually be converted to saturated solution if we added temperature and pressure on it. Okay, so let's watch this video. Saturated solution and saturated solution and super saturated solution. So credits to Najam Academy.
Well, consider 100 ml water in this object at 30 degrees centigrade. Let I add 10 grams sugar to the water. We know that 10 grams sugar is easily dissolved in 100 ml water. We call this solution of sugar and water as unsaturated solution. It is because the water or solvent has the ability to dissolve sugar or solute. Now consider that I add 10 grams more sugar to this solution. The water easily dissolves this added sugar. We know that there are now 20 grams of sugar in this solution, but still it is unsaturated solution. Now consider that once again I add 10 grams more sugar to the water and water also dissolve it. So again this solution is unsaturated solution. Finally, consider that I add 10 grams more sugar, but this time the water dissolves some sugar and some sugar settle down at the bottom. Is it still unsaturated solution? The answer is absolute no. It is now saturated solution. Because the water or solvent has no ability to dissolve further amount of sugar or solute. Therefore, we define unsaturated solution as a solution which can dissolve further amount of solute at a particular temperature. Let me repeat it. A solution which can dissolve further amount of solute at a particular temperature. While we define saturated solution as a solution which cannot dissolve further amount of solute at a particular temperature. Let me repeat it. A solution which cannot dissolve further amount of solute at a particular temperature. Now, how do you know if a solution is saturated or unsaturated? Well, let's consider these two salt solutions. Solution P and solution Q at 30 degrees centigrade. Let I add 10 grams salt to solution P and it easily dissolves in it. So solution P is unsaturated solution because it has still the ability or capacity to dissolve further amount of solute. Now let I add 10 grams salt to solution Q. But the salt does not dissolve in it, rather it settles down at the bottom of the solution. So solution Q is saturated solution because it has no capacity to dissolve further amount of salt or solute. Thus remember that solution P is unsaturated solution and solution Q is saturated solution. Therefore, this is the easy test to check that either a solution is saturated or unsaturated. Now, what is supersaturated solution? Well, to learn the concept of supersaturated solution, you must learn the effect of temperature on saturated solution. Well, consider a saturated solution of sugar and water at 30 degrees centigrade. We can see the undissolved sugar settled at the bottom in this saturated solution. Now consider if I keep this saturated solution on fire and increase its temperature to 60 or 70 degrees centigrade. We will observe that this settled sugar at the bottom will disappear and will dissolve in the water. Here is the important question which you must learn. Why the extra or settled sugar was not dissolving at 30 degrees centigrade in the water, but it is dissolved in that same water at 60 or 70 degrees centigrade? Well, it is because the space between water molecules is small at 30 degrees centigrade, while the space between water molecules is large at 60 or 70 degrees centigrade. At 30 degrees centigrade, both kinetic energy and motion of the water molecules are small, while at 70 degrees centigrade, both the kinetic energy and motion of the particles are maximum. Therefore, at 70 degrees centigrade, water dissolve further amount of solute or salt. Now listen carefully. This solution is known as a supersaturated solution because it has dissolved more amount of solute than can be dissolved by the solvent. Let me repeat it. Because it has dissolved more amount of solute than can be dissolved by the solvent. Now what happens if the temperature of this supersaturated solution decreases back to 30 degrees centigrade? Well, the space between the water molecules will decrease and the extra dissolved sugar or solute will crystallize out. Hence, we say that this solution at 30 degrees centigrade is now supersaturated solution. Because water has dissolved more amount of solute then can be dissolved by water at 30 degrees centigrade. Therefore, we define supersaturated solution as a solution which contains more amount of solute than the amount required to saturate it at a particular temperature. Let me repeat it. A solution which contains more amount of solute than the amount required to saturate it at a particular temperature. The best example of supersaturated solution is honey and different kind of candies. To summarize my lecture, we learn that unsaturated solution is a solution which can easily dissolve further amount of solute at a particular temperature, while saturated solution is a solution which cannot dissolve further amount of solute at a particular temperature, and supersaturated solution is a solution which contains more amount of solute than the amount required to saturate.
All right. So, based on your observations, I want you to determine if the given solutions are either unsaturated, saturated, or supersaturated. Let's have number one. A 500 grams of flour completely dissolved in 1 liter of water. What do you think is the answer? Yes, great. That is unsaturated solution. Number two, when another 200 grams of flour was added in the solution, the additional flour was not dissolved completely and settled. That is great. That is saturated solution. Number three, the solutions cannot hold any more solute when added in the solution. That is considered as supersaturated solution. Great job. And the last one, 1/4 spoonful of sugar in a cup of coffee. That is classified as unsaturated solution. So I am so happy that you're able to answer the questions correctly. Great job. All right, so now let's jump with concentration. So concentration is a different meaning when it comes to science because when we define concentration, that is a measure of the amount of solute dissolved in a solvent. And the unit used is grams per ml. All right, so we have here a diluted solution and a concentrated solution. Okay, so let's say we have a situation here. Number one, Jaika, can you please read? Okay, the doctor said that you should dilute the milk of your brother. What will you do and what does it mean? Okay, so when we say dilute, it means you have to put on or put in additional water to make, yes, very good. For you to make a milk for your brother, you have to dilute it. Okay, next, the chef on the television said to make a sauce, dilute gravy by adding milk and heat. What does it mean? Okay, it means you have to make the gravy less concentrated and then you have to add milk and put a heat. Yes. The maintenance supervisor told the students ammonia can be used for any cleansing job if you dilute it with water. So what does it mean? Yes, very good, Jacob. It means that you cannot use the ammonia alone for cleaning, but rather you have to dilute it, which means you have to get some water and ammonia and then combine it. So there comes a diluted ammonia. You can now use it for cleaning purposes. Yes, great. So we have here described as dilute if it has a low concentration of solute dissolved. There you go. So we have here the solute. You can see the circles. Okay. Wait for a while. This one. These are the solute dissolved. And the blue ones represents the solvent. So when we say dilute, there is a low concentration of solute dissolved. There is still greater amount of solvent than the solute. When we say concentrated, if it has a high concentration of solute dissolved, so it's what you can see, the solute has more percentage rather than the solvent. Actually, when your mother or your father asks you to go to a pharmacy and then they want you to buy a syrup, sometimes the pharmaceutical personnel ask you if you want to have a diluted solution or concentrated solution. So now, since you already know the meaning, when we say diluted solution, it means that is less concentrated. Okay? When we say concentrated solution, it means there's a lot of solute dissolved. Okay, good. So let us now go with the computation. So in this computation, percent by mass and percent by volume is used in chemistry for us to have a quantitative data in terms of measuring the amount of solute and the amount of solvent for us to make a concentrated solution. So percent by mass is a ratio of a measured amount of solute to a measured amount of solution. So for us to solve percent by mass, we are going to use the formula mass of solute over the mass of solution, and you have to multiply it with 100. So I have here steps by steps on how you're going to calculate the percent by mass or volume of a given solution. So you have to follow the steps. Number one, identify the mass or volume of the solute given in the problem. Number two, determine the mass or volume of the solution if not given the problem by adding the mass of the solute and the mass of the solvent. Number three, divide the mass or volume of the solute by the mass or volume of the solution. And the last step is you have to multiply the result by 100%. So for you to understand it more, let's have a sample problem. Okay, so the sample problem is, what is the percent by mass of sodium carbonate in a solution containing 20 grams of sodium carbonate dissolved in 600 grams of water? So we are going to use the GRESA, the given first, followed by required, equation, solution, and the answer. So let us analyze the problem. So the given is we have, yes, Liza, okay, that's correct. So we have 20 grams of sodium carbonate and yes, 600 grams of water. So what do you think is the required in this problem? Yes, that is the percent by mass. So what is the equation again for us to solve the percent by mass? So we have percent by mass is equal to the mass of solute over the mass of solution multiplied with 100. So now, let us now have the solution. So percent by mass is equal to mass of solute, that is 20 grams of sodium carbonate, divided with the mass of solution. So in this problem, it's not yet a solution because We have 600 grams of water, which is our, for us to make a solution, please do not forget, we need to have a solute plus a solvent. So in this problem, as what you can see in our solution, we added 600 grams of water, our solvent, plus the 20 grams of sodium carbonate, which is our solute, for us to make a mass of solution. All right, so there you go. 20 grams divided by 620 grams, that will be very good. That is 0.0322. And then you have to multiply it with 100. So what will be our final answer? That's correct. We have 3.22%. So that is now the percent by mass of sodium carbonate. Okay. Is that easy? Of course it is. Okay. Next problem to be solved by Josh. So the problem is, what is the percent by mass of sugar in a typical can of cola? A cola has a mass of 355 grams, and of that, about 36 grams of sugar. Okay, let's have now the given, Josh. 36 grams of sugar, that's correct. 355 grams of cola. Okay, that is now a solution, not a solvent anymore. Required, that is percent by mass. How about our equation? Percent by mass is equal to the mass of solute over the mass of solution multiplied with 100%. So the solution will be percent by mass is equal to 36 grams, our mass of solute, divided with our mass of solution, that is 355 grams. So the answer will be 0.1014 times 100. So the final answer will be 10.14%. Wow, great job. Okay, so now we already know how to calculate percent by mass. Let us now go with percent by volume. So percent by volume describes solutions in which both solute and solvents are liquid. Of course, percent by volume, it must be liquid. The solute should be liquid in form, and the solvent should be liquid in form also. So the volume of the solution is the sum of the volume of the solute and the volume of the solvent. Just the same with the mass of the solution. For you to get the mass of the solution, you have to add the mass of the solute and the mass of the solvent. In here, percent by volume, you just have also to add the volume of solute together with the volume of the solvent for you to get the volume of the solution. So what will be our formula? So our formula will be percent by volume is equal to the volume of solute over the volume of solution times 100. Yes, that is correct. So let's apply it with a problem. So the problem will be, what is the percent by volume of ethanol in a solution that contains 45 ml of ethanol dissolved in 125 ml of water? So let's see. Okay. So for the given, we have correct 45 ml of ethanol. What is this? Is this the volume of solute or the volume of the solution, Jack? Very good. That is the volume of the solute. Yes. How about the volume of the solution? Do we have the volume of the solution? Not yet. What we have is the volume of the solvent. So for us to get the volume of the solution, what should we do? Very good. We have to add the volume of the solute to the volume of the solvent. So let's do it. So we have 45 ml plus 125 ml. There you go. So the total will be How many? That will be 170 ml. That will be now the solution. So for the required, that will be percent by volume. Our equation will be percent by volume is equal to the volume of solute over the volume of solution multiplied with 100. So let's see. Percent by volume is equal to 45 ml of ethanol divided by 170 ml of ethanol solution. So the answer will be 0.2647, correct? And you have to multiply it with 100. Please do not forget. So the final answer will be very good. That is 26.47%. Great job. Okay, so now we are done with the calculation, the percent by mass and the percent by volume. Let us again recall, how are you going to solve a percent by mass problem? Yes, very good. That is percent by mass is equal to the mass of solute divided by the mass of solution times 100. Okay, how about the percent by volume? Very good. Percent by volume is equal to the volume of solute divided by the volume of solution times 100. What are you going to do if the volume of solution is not given? Okay, great. You have to add the volume of solute with the volume of the solvent. How about if the mass of solution is not given? Just the same, add the mass of solute together with the mass of the solvent. Okay, so now let me give you the lesson summary. So again, we have a solution. What is a solution? A solution is, okay, a combination of two substances, namely the solute and the solvent. When we say solute, that is the one being dissolved by the solvent, and the solvent is the one dissolving the solute. That is the bulk of the solution. Okay, and please do not forget that a solution is a homogeneous mixture. So we have here kinds of solution based on saturation. Let's see if you can answer it. What is again saturated solution? Okay, great. Saturated solution is, we have now the maximum amount of solute dissolved and the saturation point is already reached or achieved. How about supersaturated? When you say supersaturated, there is already a crystal forming beneath, and a supersaturated solution can be converted to saturated solution once we heated up the, okay, when we heated up the supersaturated solution. How about unsaturated solution? Very good. When you say unsaturated solution, less amount of solute dissolved in a solvent. Okay, that is correct. How about the factors affecting solubility? Can you please name the 5 factors? Okay, so we have the nature of solute and solvent. We have the principle, the rule of thumb, like dissolves like. So polar solvents dissolves the polar solutes. The non-polar solvents dissolves the non-polar solutes. And number 2, we have the temperature. Very good. So in solids and liquids, if you increase the temperature, the solubility also increases. But in terms of gases, it is inversely proportional, which means when you increase the temperature, the solubility decreases. And we also have number 3, the pressure. Number 4 is the particle size. Yes, the greater the size of the particle, the lesser the solubility. The smaller the size of the particle, the higher the solubility. And the fifth one is the mechanical stirring. Okay, great. And how about the concentration? When you say concentration, what is the unit? That is gram per ml, right? So we have the percent by mass and percent by volume. So for you to get the percent by mass, your formula will be, okay, that is the mass of solute over mass of solution times 100. How about percent by volume? So for the percent by volume, you have volume of solute over the volume of solution times 100. Okay, so before we end up our lesson class, I want to share with you a quotation which says that life is chemistry. Dilute your sorrows, evaporate your worries, filter your mistakes, boil your ego, and then you will get the pure crystals of happiness. It means that when you have a lot of problem, what you have to do is you have to lessen that problem. How are you going to lessen that problem? You have to make solutions, okay? And you also have to evaporate your worries. When I say evaporate, those words should be gone. Yes. Next, how about filter your mistakes? When you say filter your mistakes, you have to know what is that specific mistakes and what you have learned with that mistake. And you have to boil your ego, which means you have to what? You have sometimes to lower your ego and learn to understand other people. You know what, class, for you to be happy, you need to always put yourself on the shoe of others. In this pandemic times, we should be more understanding and we should be more patient. Okay, so for our last slide, that will be your assignment. So I want you to answer the activity. Just can get enough experiment that is actually preparing saturated, and super saturated solutions. So you have to prepare the materials, follow the procedure given in the activity, and you have to answer the guide questions. So that's all for today. Thank you for attending, and I hope that you learned a lot in this lesson, and I hope that you're going to apply what you have learned today in the upcoming battles in your life. So thank you so much, and see you next week. Keep safe, and God bless, class. Goodbye. Goodbye, everybody.